Hello. As we did in our previous lecture, we start this discussion also from the review of formulas. So the intensity at the screen due to single slit diffraction is I equal to I naught sin square alpha upon alpha square, where I naught is the incident intensity and alpha is given by this expression. This theta is angle of diffraction, and the intensity at the screen due to double slit diffraction is given by I equal to 4 I naught sin square alpha upon alpha square into cos square beta, where beta is given by this expression. The maxima due to single slit are of two types. One is principal maxima at the center, alpha equal to 0 or theta equal to 0, and secondary maxima is given by alpha equal to plus minus m plus half pi, and the condition becomes E sin theta m equal to plus minus m plus half lambda. The maxima due to double slit diffraction theta equal to plus minus n pi or E plus d sin theta n equal to n lambda. This m and this n both are the natural numbers. The minima due to single slit is given by alpha equal to m pi or E sin theta m equal to plus minus m lambda, and the same due to double slit diffraction is given by beta equal to plus minus n plus half pi or E plus d sin theta n equal to plus minus n plus half lambda. The order of missing fringes in case of double slit diffraction were given by n equal to E plus d divided by E times m. Now, the grating is an arrangement consisting of a large number of parallel slits of the same width and separated by equal opaque space. And the gratings are of two kinds. One is plane transmission grating and another is plane reflection grating. In the reflection grating, the light which incident on the grating is reflected back. The wavelets proceeding from all the points in a slit along the direction theta are equivalent to a single wave of amplitude r starting from the middle point of the slit. If there are n number of slits in a grating, then we have n emitted waves from each of the slit. So this is a slit, this is another slit, and number of these slits is capital N. And the separation from one slit to another slit is given by d. Therefore, the distance from center point of one slit to the center point of adjacent second slit is given by E plus d, and this E plus d is known as grating element for a given grating. The path difference between two waves emitted from first and second slit will be E plus d sin theta, and the corresponding phase difference between two consecutive slits will be 2 pi by lambda times E plus d sin theta. Therefore, the problem of determining the intensity in a direction theta reduces to find the resultant amplitude of capital N vibrations, each of amplitude A naught sin alpha upon alpha, and having a common phase difference between consecutive diffracted waves, delta is equal to 2 pi by lambda E plus d sin theta. And the resultant of capital N slits is given by R star is equal to R times sin capital N delta by 2 divided by sin delta by 2. Here this R is the amplitude of the light ray emitted from each of single slit, and this capital N is total number of slits in the grating which are illuminated by the incident wavefront. Here this delta is phase difference between two consecutive diffracted light rays. This delta can be written as twice of beta, so that this delta upon 2 will be beta. So this whole can be reduced to R star equal to R sin n beta divided by sin beta. This R means A naught sin alpha upon alpha. A naught is the amplitude incident on any single slit. So this will be the final expression for the resultant amplitude at the screen due to grating. So the intensity will be the square of amplitude. So intensity due to grating will be I equal to I naught sine square alpha upon alpha square sine square capital N beta divided by sine square beta. Having this expression for intensity at the screen by grating, we can check the validity of this expression for double slit arrangement also. For this, we will have to put the value of this capital N equal to 2. So if we put it, this expression reduces to I equal to 4 I naught sine square alpha upon alpha square multiplied by cos square beta, which is indeed the expression for double slit pattern. In this expression, the first term sine square alpha upon alpha square is due to single slit diffraction, whereas the second term is due to grating. Now, the principal maxima due to grating will be the position of maximum intensity. So in this expression, the intensity will be maximum if this number is minimum. The minimum value of sine beta is 0. Beta is equal to plus minus n pi, and beta is given by this expression. So the condition for principal maxima becomes E plus d sine theta equal to plus minus n lambda. If we find the intensity at principal maxima, we will put beta equal to 0 in this expression. So as we put beta equal to 0, this expression becomes capital N. So the intensity of the principal maxima is this whole multiplied by the value of this expression, or I equal to I naught sine square alpha upon alpha square multiplied by capital N square. So there are a number of principal maxima. If we talk about the minima means minimum intensity, and that minimum intensity will be given by this sine capital N beta equal to 0. So this, if sine n beta equal to 0, this n beta will be again plus minus an integer times of beta. Previously, for principal maxima, this was beta equal to integer times pi. So there is difference between this n and this m. Using this expression, the condition for minima becomes capital N times E plus d sine theta equal to plus minus m lambda. We can see here that the value of m can be 1, 2, 3, 4 and so on, but the value of m cannot be 0. If it is 0, then this condition becomes E plus d sine theta equal to 0. So with m equal to 0 is a condition for principal maxima. So if we are talking about the minima, we will not take the value 0 for m. Again, if we put this small m equal to capital N or twice of capital N or thrice of capital N, then that capital N can be cancelled by this capital N, and this condition will reduce to this condition. So if we are talking about minima, we will not take the values of m as 0, capital N, capital 2N or 3 capital N and so on. So the values of m are only 1, 2, 3 or capital N minus 1. So there are one maxima at m equal to 0 and there is another maxima at m equal to capital N, and between these two values there are capital N minus 1 values for m. Therefore it can be said that between two adjacent principal maxima there are capital N minus 1 minima. So it can be said that there are capital N minus 2 maxima between two adjacent principal maxima. Now, to find principal maxima, we can also differentiate this expression with respect to beta. So that differentiation should be equal to 0, or this will give you the condition capital N cos n beta sin beta equal to sin n beta cos beta, or this can be also written as n tan beta equal to tan n beta. So for a secondary maxima, this is also a condition. If we wish to find the intensity at second maxima, we need to have the value of this term. Using this value of tan n beta, we can find the value of sin n beta, and that will be, if we put the value of sin n beta in this term, then this term becomes this, and then the ratio of intensity at second maxima and intensity at principal maxima will be this. We have already computed the intensity of principal maxima in the last slide, and the secondary maxima intensity can be given by this term multiplied by this term. So this ratio is this thing. Here we see that the ratio between intensity at second maxima and intensity at principal maxima is inversely proportional to capital N square. More the value of capital N, less is the value of this ratio. Or as n increases, the intensity of second maxima relative to principal maxima decreases and becomes negligible when capital N becomes very large. So we have some informations. We have a multiple principal maximas with a very high intensity. We have capital N minus 1 minimas between two principal maximas, and we also have this term. This is due to single slit diffraction, where this alpha is lesser than the value of beta, and with increasing theta, beta increases very rapidly with respect to alpha. So this is the envelope of the intensity profile as in the double slit diffraction pattern. So the pattern by grating becomes like this. This is due to sin square alpha upon alpha square, and these are principal maximas. This is for n equal to 0, this is for n equal to 1, this is for n equal to 1, and there are capital N minus 1 minimas, and between these two principal maximas there are capital N minus 2 secondary maximas. So this is the pattern due to grating. When these two patterns are multiplied to give final pattern, this becomes like that. So the principal maxima or the central principal maxima is highest because multiplication of these two values, and the principal maximas for n equal to minus 1 and n equal to plus 1 are the maximas of intensity lesser than that of principal maxima corresponding to n equal to 0, because multiplication of this value and this value. So this is the final pattern due to grating at the screen. As this capital N becomes very large, these secondary maximas become negligible. So for a grating where this capital N is around 15,000 lines per inch, these secondary maximas are invisible from our eyes. We can see only the principal maximas. This is the example. If we have a grating placed here and a light wavefront of a given wavelength is incident on this grating, on the screen we find this type of intensity with maximum intensity at this place where principal maxima of order 0 is placed. This is for principal maxima of first order, this is for principal maxima of second order, and minimas and maximas are here which are invisible because capital N is very large. So we make the light incident on the diffraction grating and we get a number of maximas on the screen. This is another example. Due to double slit, we have these maximas under the envelope of single slit. This is the pattern by 3 slits. So as we know that the secondary maxima are capital N minus 2 in number. and here capital N is 3. So we will get a secondary maxima between two principal maximas, and the number of that secondary maxima will be 1. If we have 4 slits, capital N minus 2 means 2. We have 2 secondary maximas between two principal maximas. If we have 5 slits, we will get 3 secondary maximas, but as the number capital N is increasing, the intensity of secondary maxima will decrease. So as we go a large number of slits, we cannot see the secondary maximas. Only the principal maximas will be visible. Like we have found the missing spectra in case of double slit, we can also find the missing spectra by the same way in the grating also. So in the grating, the maxima due to grating is given by E plus D sin theta equal to n lambda, and minima due to single slit is given by E sin theta equal to m lambda, because final expression is the multiplication of the pattern by grating and by single slit. So if at a single value of theta, minima by single slit and maxima by grating both lie, then those maximas by grating will be absent from the spectra, and the order of those missing spectra can be given by the ratio of these two expressions. So we can have n upon m equal to E plus D divided by E. So this n is the order of missing spectra in grating, and this m is integer number. So if E equal to D, then n will be twice of m, and if D equal to twice of E, then n will be equal to 3m. So in this case, even orders will be missing, and in this case, 3rd, 6th, 9th, 12th order are missing, and in this case, 4th, 8th, 12th orders are missing, and so on.